A-level statistics, measures of spread, box and whisker diagrams. Let's have a look at box and whisker diagrams. Box and whisker diagrams are a good way of visually demonstrating the spread of a set of data. Suppose we have a set of data such as the list of numbers below. We can find the maximum and minimum values, the upper and lower quartiles, and the median. Now the minimum value is 2 and the maximum value is 17. With 13 terms, the median is the 13 plus 1 over 2th term, that is the 7th term. Now the 7th term is 8, so the median is 8. Now there are 6 terms on either side of the median, so the quartiles are the mean of the 3rd and 4th terms in each half. So in the lower quartile, that is the mean of 4 and 6, so 4 plus 6 over 2 is 10 over 2, which is 5. And the upper quartile is the mean of 13 and 14, which is 13 plus 14 over 2, or 13.5. Now we can draw a box and whisker diagram, and it's best if we draw it on graph paper. We must first of all include a scale stretching from the minimum value to the maximum value. We now draw short vertical bars above the minimum and maximum values of 2 and 17. We now draw a longer vertical bar above the median and similar bars above the lower and upper quartiles. We then complete a central box stretching across the quartiles and then draw 2 whiskers out to the minimum and maximum values. And this is our box and whisker diagram. Now if we draw a second diagram, we can make comparisons. So if we draw a diagram B, looking at the medians, we can see set B has a much higher average. Set B is more tightly packed than A, particularly in the central section between the quartiles, although the minimum value, the left whisker, stretches out quite a long way. Set A has a slightly longer tail to the right from the median, so it has a positive skew, and B has a longer tail to the left, so it has quite strong negative skew. Now if we have group data, box and whisker diagrams match up very well with cumulative frequency graphs. If we draw a cumulative frequency graph, we can easily draw a box and whisker diagram below it. We use the same x-axis scale on the graph and on the box and whisker diagram. Now since we don't know the minimum value, we assume the minimum value is 10. We look down from the graph to the diagram and mark the minimum point. Similarly, we assume the maximum value is 90 and look down to mark the maximum point. We then draw the median in the diagram directly below the median in the graph. And also we draw the lower and upper quartiles directly below the graph. We then complete the box and the 2 whiskers. And we see that the cumulative frequency graph and the box and whisker diagram can be made to line up exactly one underneath the other. Or we could simply read off the minimum value, which is 10, Q1, which is 40.7, Q2, which is 51.1, and Q3, which is 61.3, and then the maximum value of 90. We can then plot these on a scale on graph paper to get the box and whisker diagram. Comparing box and whisker diagrams. Now one of the main reasons for drawing box and whisker diagrams is to compare different sets of data. For example, we can compare how 3 classes in a school did in maths and in history exams. The diagram opposite shows the lowest mark, the quartiles, the median, and the highest mark in each subject for each class. We can straight away see in mathematics that there's quite a difference in the performance of each class. Perhaps the classes had been arranged according to maths and science ability. Overall, Class 10AH had the weakest results in mathematics, although at least one student did very well. Class 10JT on average did the best in mathematics, and we can see that at least one student scored full marks. In history, the classes were more evenly matched, with Form 10KR having a slightly better median mark than the others. However, its marks were a little bit more spread out. Although slightly below the other classes, overall 10AH had quite good history results. Such a diagram does give a quick visual overview of all the results.